Good evening all, Namaskar. I'm thankful to IWWA, Mumbai Center and this convention team for having me here. So Professor Emily has very nicely laid out the water quality perspective about IWS versus continuous water supply. So it will be very easy for me to pitch what I'm going to say. She has given a good context about water quality. So since morning we have been discussing about reliable, resilient water supply systems or overall water infrastructure. So first you have to understand what is sustainability. Sustainability can be defined by 5 parameters. Something that is environmentally prudent, something that is economically acceptable, affordable, socially acceptable. Governance, a lot of discussion happen on PPP and other models, so governance has to be easy. It has to be technically replicable by our own engineers, our own municipalities. So these are the 5 parameters I think every technology or any alternative should be evaluated. Now, in today's time, we talk about resilience, which is another expectations from the engineers to add to sustainability. We have been trying to achieve sustainability, now the era is of resilience. So resilience is a concept from nature that every one of us is resilient. We have been resilient in COVID times. We have shown resilience as a person, as a community, as a city. Similarly, infrastructure resilience is a new concept. And water resilience is the capacities of cities to function in the face of water-related stresses so that those living or working within the city can survive and thrive. And many such catastrophic events are happening, so resilience is very important. Now, our designs that we are doing has to be adaptable, flexible, and robust at the same time. So all our new planning and design guidelines has to consider these 3. What does it mean? That on x-axis you have a timeline, on y-axis you have performance of infrastructure, and the performance can be measured by, let's say, supply hours, LPCD, how much water access, and many other parameters. So your reliability may come suddenly down by, let's say, flood or any drought kind of condition. So as soon as the reliability goes down, how quickly you can bring up the reliability is the resilience, okay, in the simplest term. So a lot of knowledge needs to be created about resilience, how we can be resilient as a city infrastructure or a rural water infrastructure. So again, these 3 parameters you have to assess whether the future systems, water systems are adaptable, flexible, and robust. So 5 sustainability parameters and 3 resiliency parameters we have to understand if we have to define something as futuristic water supply systems. So both the perspectives are very essential, that something, whatever we are doing today has to be sustainable and also has to be resilient. Okay, so some of the discussions I'm going to make is with these terminologies. So me and my research group, we study a lot of water supply systems across India. Whatever I'm going to say is based on this field. So this is not like I'm very theoretically I'm saying. I've seen what happens on field in many states. We work with state governments, field surveys and measurements our team does. We understand what is happening in the ground. A lot of training programs, international studies we do, workshops we do. We have studied 24/7 projects across Nagpur, Coimbatore, all these projects we have studied. So what I'm going to say is based on all these field observations. So a lot of traditional knowledge exists in our country which is basically getting forgotten. Our traditional water supply systems have been resilient, okay? So we are a country which has a tremendous amount of traditional and cultural heritage which we are forgetting. So a lot of such rainwater harvesting structures, very innovative shaft kind of structure did in 1970s by our own Maharashtra Jeevan Pradhikaran engineers. A lot of innovative structures are there which are not studied, which are not brought to in today's time. So all the knowledge has to be contextual to our conditions. So this is a lot of knowledge we are missing from our own engineers and people. I think we should focus on that. So what are the challenges in the water sector? We'll see. So we are stuck in a vicious cycle. Since morning we are discussing what is happening. So infrastructure condition is poor. That means city water infrastructure or any water infrastructure is poor because of planning guidelines are not suitable, analysis is not happening as per our local conditions, design is not happening as per our local conditions. That leads to a poor service quality, that leads to poor consumer satisfaction, that leads to poor revenue generation, and that leads to poor operation and maintenance. So unless we don't solve this vicious cycle, which is studied by our PhD student Dr. Anuj Gorpade, his PhD dealt with this, that how to break this vicious cycle. Unless and until we will not find the solutions to come out of this vicious cycle, our water supply systems will not be futuristic. So the current reality is intermittent. We have alternate days in some cities, like these cities have once in 7 days, inequitable distribution. Situation is similar irrespective of water availability. So whether there is water or there is no water, we have a tremendous amount of challenges. The root cause is the water management problem is wicked problem. What wicked problem means is that you try to solve the problem, it becomes more complicated because the solutions are not thought holistically. Like two people are fighting and you go an expert and actually you increase the fighting instead of solving the fight. That's what is happening in the water management, okay? So whether the current designs are working, that we have to consider, because our entire theory is based on this peak factor theory that comes from our 24/7 design guidelines. But everywhere we are saying there are storages, right? Whether you go to a rural area, you will find such kind of storages, 2 to 3 days storages. People are using pumps, people are storing water, and high-rise buildings are also storing waters. So our design guidelines doesn't talk to what ground reality is, okay? So the design remains highly theoretical, and hence expecting that a new DPR, a new project will solve the problem is fictitious. So our hydraulic models have huge data gaps. Our hydraulic modeling techniques itself are not suited to our local conditions, okay? All the hydraulic models are demand driven. That means it assumes that everything is dependent on the demands are fulfilled, which is not. Our models are withdrawal driven, that how much consumers can withdraw. So this is a reality that many cities are not receiving water, and this is every year we see this news. So forgetting all of this, there is a quest for 24/7, that every forum I go and people talk about 24/7. So this is a long narration and the program since 2000s where World Bank funded 24/7 projects started. I have not seen a successful 24/7 project. These are still planned, still getting implemented. Completions are not there. What is new in the 24/7? Because if the design doesn't change, this is 1980s. Our own engineers have operated Pusa, Yawatma and Wani in 24/7, okay? So this is done, already available. That knowledge is available with us. We don't need a new companies, new kind of knowledge set. This 24/7 is a hardcore engineering, and that engineering knowledge is available with our municipal engineers, our Maharashtra Jeevan Pradhikar engineers, with our any government engineers, okay? So only they have to given an opportunity to work with a free hand and take the systems control. We do not need a very fancy project to do 24/7. So what's wrong with the current 24/7 projects is assumptions are flaws. That there are very faulty assumptions that you will convert one zone and you will do the next zone. As soon as you focus on only one zone, rest of the zones do not get attention. Pilot selection, I have seen in many 24/7 cases, the pilot is where you supply more water, which is the easiest pilot area. That is the bias in the selection. And we have to understand the consumers. I have seen in cities where 24/7 is there, but still people are storing the water. So consumer behavior, and as Professor Imli has said, water quality affects how, based on how consumers receive the and stores the water. So is it prudent to supply water 24/7 where the water network losses are 30 to 50%? Can you imagine that losses are there and still people are going for 24/7? So this is my own first-hand experience. I had done a third-party evaluation and submitted a report where except 2 to 3 pilot demo studies in this city, there was no 24/7. NRW is more than 30% across all the zones. Consumer complaints remain the same. Most households continued to rely on groundwater level sumps. NRW levels were high, and this entire these efforts, the tariffs were increased, service has not increased. Okay, so this kind of situations, do we need this kind of projects? We have to think. So what should be the aim then? I should not talk about problems but the solutions. So aim should be that unless and until you do not achieve these 5 benchmarks, that water supply, the source availability should be more than the total demand and system losses, the cost recovery should be greater than 90%, total losses should be less than 15%, more than 95% household should be having access, and there is a reliability. If the city has a daily water supply, only those cities should be chosen for 24/7 and all other parameters achieved. So you may want to jump from unhealthy state to the healthy goal, which nobody can deny, but if there is a direct jump, it is going to be accident, okay? So this is what is happening, that municipality which is want to have advice, a commissioner or a municipality wants to have advice, there are people who are advising directly go for a digital solution, AI, and I will be very blunt here, AI digitization is a final step in the game. It is not the first step in the game. We have to work on the basics, we have to fix our basics, then only we can do it. So you may be happy to appoint a consultant who just put a smart watch and declare you a healthy person. That doesn't work. You have to have a person who can, every day you can work, exercise, then only you become healthy. Similarly for municipalities, you have to do a daily exercise of water losses. So the way ahead is that we have to do a complete circular economy kind of model. We have to improve the decentralization. We have to apply indigenous knowledge, local solutions, and community involvement, policy governance, and innovation in technology. Whatever technology is available, we have to identify whether it is suitable. If you are going for 24/7, the 5 benchmarks I given, those should be followed. If you want to do digitization and some digital twins, the benefits of those has to be ascertained first. Else you will, all these fancy projects will move away attention from working on basics, and that should not happen, and our cities and our water infrastructure will not come out of the miserable condition that we are in. Thank you.